Okay, well, let's take a look at this third guided project. I have the project description up. It's got some objectives, some technical background, and here it introduces what we call an affine model or straight line model. So now we get to our y equal mx plus b, and it talks about the point slope form here. So often we may know a point on a straight line and the slope, and so we can get an equation for the straight line this way, and then we can determine b. I have a formula for b, but the derivation is that we just multiply through this expression by m, get that, and work it all out. And so we see an example. So this is all just some background, making sure everybody's on the same page, so to speak. Now then, this says, suppose we have some data. What can we do to try to get a nice line? And what this suggests is to get our point. Okay, so if we have a point and a slope, we've got our line. Well, to get our point, we'll take the average of the x's, the average of the y's, and use that point. In this case, with these numbers, that would be the average of the x's is 3, the average of the y's is 4, and so we're going to use the point 3, 4, and plug that in like this, and then try to find the slope. And then what we'll do to find the slope is really a lot like what we did in the previous module, because once we put this into Desmos, we'll get a line. We'll get a slider for m, and then we'll get a line that always goes through our averages, the 3, 4 that we had here. So it always goes through 3, 4, and and then by giving different values of m using our slider, we can try to decide on our best fitting line. And so in this little example, it was the -2. -1.5 was not steep enough here to really capture the data. -2 looked pretty good. There's 2 points below, 2 points above. That's pretty nice. And then if we go to -2.5, that's a little too steep. That point looks to be on the line, but these two are below and that one's above, and so I think the -2 did a little better. Okay, so we would have our line -2 times x minus 3 plus 4, and then we would change it to the slope-intercept form here with the y-intercept simply by using the algebra here and the arithmetic to simplify it. Okay, so that was all the background. And then, this says, okay, go to Blackboard and open up the same file we used last time. Now, that file is in Project 3, so there it is. And I click on that, and it says open with my spreadsheet, and so I say sure. I'll open that with my spreadsheet. I'll change it to edit, and I should probably save it to my drive, somewhere. I'm not going to do that right now. So, so I have it. Okay, and Where's my, oh wait, it's up here, isn't it? There's the project. So I've opened it up, and yep, that's that same one. And now what we're going to do is, really kind of go through the same sort of thing we did for Module 2. We're just going to do it in Module 3 with a slightly different model. We're going to go for an affine model. And so this says, hey, let's add our data to Desmos. So I need Desmos. Somewhere it says open Desmos. Yeah, so it says open Desmos. So I go here. I'll go to Desmos. If it doesn't automatically sign me, so this one, it knew who I was on this computer, and so it signed me in, so I'm all signed in. And then it says, copy my data like we did before. This time, I just suggest this is the way you do it, is just use the spreadsheet, because we're going to use the spreadsheet to find averages. And actually, we could use Desmos to find the averages, but if you don't know how to find an average with a spreadsheet, you need to learn how to find an average with a spreadsheet if you want to be a college grad. I just think you ought to do that. And so we're going to use a spreadsheet. And so we're copying our data, we're putting it in here, and hopefully it'll look like that again. So I need to go to my data. I don't need that. Okay, I need to go to my data, highlight the first two, columns B and C. I'll copy it. Go here to my graph, and I have to use Control V to paste it, but I paste it, there it is. And there we have it, there are my data. Now again, I can change that to a D and that to a T, uppercase T. And, that says do that. Save your graph. I'm not going to save it, but, you just click save and give it a name, a reasonable name, and you should be good. And so now we need to have our averages. So if you happen to copy that data and close your spreadsheet, it says open it back up again. And what we need are X bar and Y bar, the averages. And we're going to put those at the bottom. And so I go here, I'll click there, and I'll say X bar and Y bar. And to get those averages, we just say equals average. And most spreadsheets kind of show you that you are probably on the right path by giving you some things here. And then I'm just going to go up here and click and highlight. And you see it fills those in. And do a closing parenthesis, hit enter. Now what's great is if I copy and then I paste, it automatically fixes up the formula. See, now it's looking from here to here. It automatically changed the B's to C's because I moved over a column. So that's one way to copy and paste. Another way is you can just drag. If I'm here, usually on most spreadsheets you can grab this bottom right corner, drag it over. That was another way to copy. So there we go. I have my X bar and Y bar of 5.485 and 12.85. So I did that. And so that's what this section is asking me to do, is find the average of those cell addresses. And so there's the command, and I get it. And now it says you're going to include this, include something like this in your spreadsheet. So something for like figure 1.9. Now all you have to do in your spreadsheet is, if I go here and I highlight those and I copy, So I just highlight those, I copy them. Now I don't have a document up, so I need to go find my, there we go. Oops, I accidentally think I opened two of those. Maybe not. But anyway, there's my document, and you know, I probably need to leave some room to put picture, you know, images or various things like that. But I am going to need that table, and I just want to show how easy it is to do the table. So if I paste now, there's the table. Okay, so it was that easy to put those in. All I had to do was highlight and copy them here, then go to my document that I'm making and paste where I wanted it. And you know, once I have it here, actually it allows me to move it around. You know, it's centered it quite nicely and so forth. So there you go. I have my table. Let's go back then. So I found those averages, and then now fitting the line. So what I have to do is put in this model right here into Desmos. And so it says put that in. And again, I need to use a Y and an X because otherwise Desmos might start getting confused. So, you know, I go to my Desmos and I come down here to this spot. And there's my Y equals M. What it thinks M is, I'm not sure, but it seemed very happy. Y equals M. And then X minus, now notice it for a minute there it said add a slider, 5.485 I think was the answer, and then plus 12.85, and then add our slider. And actually it's interesting, when I add that slider and the slope is 1, that really doesn't look too bad. Here, let me make that brighter, bigger, and all that. You know, looking at that, that really looks pretty good. I was surprised. I hadn't really thought about what the slope might be, but there, and I can recenter things and zoom and all that to make it look better. But yeah, that looks pretty good. Actually, though, I think what looks slightly better is around 0.8. So I'll just make it that. And you know, I could have made the slide better by putting, say, 0 there and maybe 1.5 here. And then I can, you know, slide this around and look at it. But I felt about 0.8 looked pretty darn good. And so for this project, you know, I suggested you just go with the 0.8. So there's the original slope of 1, and then I changed it to the 0.8. And you know, looking at those two, there is not a whole lot of difference between those. Right, very little difference. But anyway, I went with the 0.8, and part of it is just showing that we can change it. You know, if you think the one actually looked better, well, that's fine. On these others, you'll get your chance to take care of that. And so, you know, do whatever slope you think looks best. But on this one, let's use 0.8. And so, you know, there's my point slope form right here. And then I need to get to the slope intercept form. So the slope is 0.8, the y-intercept is 8.462. And then I suggest, just to check it, put that model in and make sure it lands right over. So this is to check your work here. Go back here and we'll type in a new one, y equals m oops, well, m, I can use that m or use the 0.8, x, and then plus, and that number again was 8.462. 8.462. And there we see the blue line is right on top of the black line. If I click that and make the blue line disappear, there's the black line underneath it. So yes, that's the right model. And so now I have my slope-intercept form. And it says save my graph. Create my screenshot. So of course, here, I want to show everything. So that's about right. So there, I have my data, my line, my model, and my two representations. And so I can do my control print screen, and again go to my document. And down here somewhere, I can paste, and there it is. It's much too big, but also I probably want to crop it a little bit. So again, let's see, to crop this thing. Oh yeah, there's the crop tool for that. So I'll bring it down where you can still see my name. Bring this one over. I don't need that stuff. And there we go. Now it's probably too big, and it's sitting over my table. So, now I want to, move it down here. There's my table again, and I'll want to probably write things in between. And if I still think it's a little too big, I can, probably to make it look best, go from the corners. And there it is. And move it up a little bit. And there's the X bar and Y bar. And so I'll need to write all my other stuff in there. Oops. Okay, so I have that. And then I need to evaluate this thing at 2, 3, and 4. Now actually the easiest way to do that could be to go back here and use what we call the f of x notation and say f of x equals. And then if I say f of 2, I get 10.062. If I say f of 3, 10.86. F of 4, 11.662. So, there I very quickly got my evaluations. And, in a less quick way, but another way I could have done this is instead of using the f of x notation and so forth, I could have just come here in the calculator and said 0.8 times 2 plus 8.462, and there it is, that same 10.062. So I can evaluate it a couple different ways within Desmos. I like what we call the f of x notation, and that just is a very quick way to get that calculation. And so that's all the stuff I have to actually do for drive times. And then it says, okay, well, let's do bus time with the drive distance. Let's do bike time with the bike miles. And then bike time with the drive miles. Okay, so 3 more, but pretty much that same thing. And making a note of your model and saving your graph and all that. And then we have the report, and the report looks very, very similar in structure to the report you just did for Module 2. So I don't think this project should be too bad. You know, you can use a lot of what you did in Project 2 to help you. And so hopefully this project will be not as time consuming as the other two have been, because this is kind of a repeat of Module 2, but with a new model, an affine model. Okay, so there, I'm going to do less and less of these as we go, but there's some of me going through this project.